Hi, good day. My name is William T. Dongo. I'm here to give you a series of lecture about the climate control and refrigeration technology. The subject will be about residential and commercial heating. Okay, the first lesson we're gonna be talking about will be lesson 1. That is about gas fundamentals. In this subject, we will be talking the type of gases, okay? And then the combustion process, the requirement, gas equation, production, and combustion. And then we're gonna be talking another two all the way through here. We got introduction to heat. Okay? The first one I'll be talking about is the type of gases. What we have is natural gases, manufactured gases, and then we got liquid petroleum gases. Natural gas comes from the earth, colorless and odorless. Odor is added, and then principally methane combined with other hydrocarbon gas. It has a BTU per cubic feet is usually 1000 to 1050. Okay, lighter than air. Enter the building at 7-inch water column pressure, less than a quarter pounds per square inch PSI. And then we got the other one, the manufactured gas. Manufactured gas normally produced from solid or liquid fuel. Comes from coal or oil. Low in BTU per cubic feet. That is 5,000 to 600 BTU. Not economical for space eating fuel. And then it's lighter than air. Okay. Liquid petroleum gases. Liquid petroleum gases we call what we call LPG. A combination of propane, butane, pentane. Okay, that's propane, butane, and pentane. Colorless and odorless. Odor is added, heavier than air, will puddle in low spots, store in liquid form, but is vaporized when used. BTU per cubic feet is used usually 2850. That's 2850. Enter buildings at 11-inch water column pressure. That's very low. And then the next one we're gonna talk about is the combustion process. Combustion process. That's the one we'll be talking about. Combustion process. The requirement for combustion, you gotta have fuel, heat, and oxygen. Okay, fuel, it must be present. We can have a natural gas or a liquid petroleum gas, which is we call LPG. And then you gotta have heat. Enough heat must be supplied to bring the fuel up to its ignition point. And then you gotta have a pilot, and then you gotta have electric spark. You gotta have a pilot or electric spark to start the ignition. And then you gotta have an oxygen. Oxygen, the combustion process consume oxygen, which is obtained from the surrounding air or air supplied to the combustion chamber via small blower. Fuel, heat, and oxygen are the three elements that are known as the combustion triangle. You remove one of these elements and then the combustion will be gone. All must be present in order to have ignition and a flame. And then you got what we call is a gas equation. We got natural gas, okay, for complete combustion. 1 cubic foot of natural gas requires 10 cubic feet of air. Remember that. 1 cubic foot of natural gas requires 10 cubic feet of air plus a flame of ignition. And then liquefied petroleum gas, for complete combustion of LPG, 1 cubic foot of LPG requires 18 cubic feet of air plus a flame to ignite. So remember, you always remember that triangle that you must have in order to have a combustion. You gotta have your fuel, your heat, and then the oxygen. You remove one of those, then your flame will be gone. Okay, production of combustion. If complete combustion is taking place, the products of combustion for natural gas will be 1 cubic foot of carbon dioxide, that's CO2, 2 cubic feet of water vapor, that's H2O, approximately 8 cubic feet of nitrogen. So you have a product of carbon dioxide, oxygen, and nitrogen. That means water and then nitrogen. And then if complete combustion has taken place, the product of combustion for LPG will be 2 cubic feet of carbon dioxide, that's CO2, 3 cubic feet of water vapor, that's H2O, and then approximately 14 cubic feet of nitrogen. Okay, now once you got your fire lit up inside your furnace, and then suddenly you got an interruption of a fire, then the causes of incomplete combustion might occur. The causes of those is when a gas flame does not receive sufficient oxygen, flame impingement, okay? When a part of the flame is cooled between its ignition temperature. Production of incomplete combustion, okay? It will produce carbon dioxide, it produces a water vapor, it produces carbon monoxide, and then aldehydes, that irritates eyes, nose, and throat. And then you have a soot. So that means you have an incomplete combustion into your furnace, and those products will result. Just one of these is the carbon monoxide. That's dangerous because it might, if there's a carbon dioxide in the heater, make sure you know that you've got to buy a sensor. So the sensor will alarm you when carbon monoxide is in the house or to the premises, because carbon monoxide will just kill you right away. And then secondary air, the air that is necessary for combustion around the flame. The secondary air is the air that is necessary for combustion around the flame. And then the primary air. The primary air is the air that enters the burner with the gas. Okay? Primary air is the air enters the burner with the gas. Adjusted with air shutter on the end of the burner. Okay? Excess and lack of primary air. excess and lack of primary air. With excess primary air, the flame will be distorted and will lift away from the burner. With insufficient primary air, the flame will become yellow tips. Yellow tip, resulting in incomplete combustion. And then the other one, you have excess and lack of secondary air. With excess secondary air, the flame may possibly blow out. With insufficient secondary air, the flame will float, looking for oxygen, resulting in incomplete combustion. And then we have the different types of flames, what we call flame types. You got the parts of the flame. You got the inner cone, okay, the outer cone, and then the outer mantle, okay. And then we got blue flame and then yellow flame. Blue flame, both primary and secondary air are properly adjusted. Yellow flame causes by insufficient primary air or secondary air. Now we have the flame temperature. So we look at now the flame type, and then we're going to talk about flame temperature. Flame temperature, the highest flame temperature usually occurs at the point just above the outer flame cone. Remember that. The highest flame temperature usually occurs at the point just above the outer flame cone. And then the next one we'll be talking about will be introduction to heat. That is combustion, conduction, heat transfer. And then we have radiation, heat transfer. And then convection, heat transfer. Energy actually traveling from one molecule to another. That means this is a solid contacts of two material. A copper rod, example, a copper rod heated on one end, it moves by conduction, molecules to molecules to the other end. And then we got the radiant heat. Radiant heat, heat transfer by radiation between radiation travels through space. Without heating, the space is absorbed by the first solid object that is encountered. Example of this? No. Example of this is just like you got your what you call that? You're on a regular heater, electric heater, and then you put yourself around near to that, and then you got radiation that will be coming out on that heater, electric heater. Then you can feel hot. Okay? And then you got convection heater transfer. Convection heater transfer used to move the heat from one location to another. Heat is normally transferred into some substance that is ready movable, such as air or water. Forced convection, when a pair of pump is used to move the heat. Natural convection. Okay, natural convection, when air is heated, it expands and rises. Lighter heated air is displaced by cooler air, setting up a natural convection current. Example of this is a wall or floor furnace. Okay, this is the first chapter that main lesson that I to the new module, or this is the first chapter that I developed for commercial and residential heating. Okay, using gas. Okay, this is for training purposes only, and then thank you very much, and I hope so you appreciated the short lecture, the chapter 1, lesson number 1. Okay, thank you.